would be the weekend you should get your project done. 228. Regression. Due Tuesday. The papers are in the back. Feel free to fold them into quarters so that it actually turns out nicer if you just fold them.
Oh, does that have to be on that? I mean, mine's still big.
It's a poster, a regular poster for this thing.
I mean, mine's bigger than mine. It's probably not that size.
It is a poster, so it should be able to be used to see. Okay. If you have not, taken a picture of an example, then you probably want to do that. The example, Pittsburgh up there is really good. That's why they're up there, so you have examples to look at. And the point of the project, which, there's always one or two students who just totally miss the point of the project, okay? Is to show the work on the poster. So I like the visual examples up there. You can see how they got the midline. Okay?
So
I want to show the work. You want to show people the work to get those answers, okay? And it's a poster, so it needs to look pretty. That's the point. All right, so like one person had nothing on his poster except the graphs. And I was like,
How many points
what
did
was
they
the
get?
equation? What was your sign regression equation?
How many points did they
3.
Out of what?
get? 30. Oh, 30.
What the heck?
10%?
I'm just, it shocks me because clearly, this is free points. Like, this was not a hard project, okay? These are free points. You should not get, anything less than a 28, okay? All right. So today we're using inverse applications and models. So this is actually the whole reason why we have inverse functions, is actually solving for angle measures. So example 1, we want to find the missing side or angle, and this is a right triangle, so that's very important. Excuse me. And so on letter A here, we have a right triangle, side length 11 and 18. We want to find side W and also this angle P. And there's lots of ways to do that, but trig is definitely the easiest way. And so first, we want to find this angle measure. And that angle P, if I want to know that angle, then this 18 would be called the opposite side, right? And 11 would be called the adjacent side. And which trig function uses opposite and adjacent? Tangent. Oh, okay. So tangent of angle P would be opposite over adjacent. So I just wrote a trig equation, and I want my calculator to be in degrees. Why degrees? Because it says P degrees. That's why. All right. And so here is why. Right now, that P is trapped inside the tangent function. And if I want to get that tangent function off, tangent is not a number. I can't divide by tangent. It doesn't work that way. It's a whole function. So I need something to cancel it out, which would be the inverse function. So we actually end up taking a tangent inverse of both sides. And this is the entire reason we learn inverse functions, so that we can cancel them out. Tangent inverse and tangent undo one another, leaving P as the tangent inverse of 18 over 11. And that is something we can plug into a calculator. So tangent inverse of 18 over 11. Not that you can see that. All right, I fixed my screen, but now my sweet spot is much smaller. Okay. All right, is 58.6 degrees. I don't know what to round to. So read the directions, see if they actually specify. Okay, so that's 58.6 degrees. You need to change your setup to. I know, so you have to go to setup and change to degrees. Yeah. Yeah, you can move that. All right. All right. So radians, degrees. There we go. Okay. Okay, now I'm okay. So this is 58.6 degrees, which is kind of nice. And now that we know that, then I'm going to use a different color now. We can use that angle to actually solve for W as well. So pick a side, any side.
18.
18. Okay, the opposite side, and W then would be called the hypotenuse. And so which trig function uses opposite and hypotenuse? Sine. So the sine of our 58.6 degree angle would be opposite over hypotenuse. So 18 over W. And we want to solve for W. How do I get W by itself? Multiply by W. And then divide by the sine of, so W equals 18 over the sine of 58.6 degrees. And that, again, is something we can plug into our calculator. 18 divided by the sine of 58.6 degrees. And it looks like W is about 21, maybe 21.1. 21. Yes, you could do a squared plus b squared equals c squared. Yeah.
I started to do that.
Yeah. So that is another way to do that. You could a squared plus b squared equals c squared. The trig is pretty quick. All right. Good. It has to be in degrees.
Yeah.
Yeah.
I'm sorry. Providing W, can you just use my narrative?
Yes. Which I just said.
Oh, really?
Yeah. Thank you.
Would you like us to use what we just did?
Whatever you want to do. That's what math is about. Learning lots of ways to do the same thing. Okay. All right. So let's look over here. So first, I need to find angle D. And looking at the other information that they've given us, what trig function can I write? Sine. Sine of our angle D would be opposite over hypotenuse, so 9 over 28. How do you get D by itself? Inverse. Sine inverse of both sides. Sine inverse and sine cancel one another out. And so D is going to be sine inverse of 9 over 28. And so we can do sine inverse of 9 over 28 in your calculadoras and get 18.7-ish degrees. Okay? Got it? Yeah? Okay. And how do you want to get A?
Tangent.
Tangent? Okay. Tangent would work. You know what? I'm going to do cosine. I'm going to do cosine. Adjacent over hypotenuse. I'm going to use cosine. So cosine of my 18.7 degree angle, cosine of that angle would be adjacent over hypotenuse, so A over 28. Why did I choose cosine? Yeah, the A is already on top. That makes it easier, right? Okay, so we can just multiply by 28 on both sides and then get the answer. So 28 times the cosine of 18.7, and that's regular cosine, not cosine inverse. 26.5 feet. Does that make sense? 26.5 feet? Yeah, that makes sense-ish. Yeah, it's shorter than the hypotenuse, so that's definitely good. All right. Okay, questions on those two? So inverse functions are useful for finding angle measures. Okay. Eric?
28.
Okay. All right, I have one more. And then you get the worksheet. A sonar operator in a ship detects the submarine a distance of 400 meters away with an angle of depression of 35 degrees.
You can pull through submarine. We believe in you.
Yes. Angles of depression. We've talked about angles of depression. What are angles of depression and angles of elevation? What is very, very important?
They go down.
Down from where?
From the north, from the street, from like the south. Like I don't know how to
From
tell you.
high, from the line.
From eye level, yes. From your, we don't walk around with our heads straight up. That would be totally weird. So from eye level, how much do you have to depress your eyes or how much do you have to elevate your eyes? So when you talk about angles of depression or angles of elevation, it's always from horizontal. And what's important about that is if you have horizontals, like the water here is a nice horizontal, and this line of sight looking down here, this might be an angle of depression of say 40 degrees, then I have parallel lines. So what does that mean when you have parallel lines? Yeah, the opposite interior angle here, alternate interior angles, also 40 degrees. So parallel lines is very, very important and comes up all over the place. So these angles would be the same. Lots alternate exterior angles are congruent. So be careful. All right, so we talk about distances. Distances are directly, this is the shortest distance to the submarine was 400 meters. The angle of depression, so from water level down, was an angle of 35 degrees. And we want to know how deep is the submarine. That would be the depth. That would be depth below the surface of the water. So this would represent the depth we want to find. Trig? Which trig function can we use? Sine. Sine of our 35 degree angle would be opposite over hypotenuse, which in this case would be d over 400. And then we need to do what? Times by 400, yeah. So 400 times the sine of 35 degrees. And 400 times the sine of 35 degrees. 229.4-ish meters. Pretty deep.
That it?
Uh-huh. Do you have any questions for me?
No.
Well, 1 meter is how big?
I was never taught.
That is correct.
That's true. How many feet? 1 meter is how many feet?
It's
Five
just-
thousand.
or something. It's 13 size about
5,000.
That's 6 meters.